Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically. What am I doing? So I made a dedicated video on how you can analyze a UEFI firmware. I got two types of comments. So if you think there is a malicious code in there, how you can analyze it, and hopefully someone will be able to install core boot or something else to it. Maybe somebody will find a backdoor. Doesn't matter. So that was one type of comment, and I responded. The second type of comment was all about pfSense itself and OpenSense and all that stuff, and some of you requested that I cover pfSense setup in a house environment and how to secure your environment with a firewall in your home network. This video is for that. So I didn't change anything since the last time, literally. So this is the LAN port, and I connected the computer that I'm recording from to LAN, and this is the WAN port, which is actually connected to my real firewall, the real pfSense, and that's running my whole house, right? That doesn't matter. We're gonna go over it, and I will show you a couple of things. I did not set up anything. I'm not going to walk through some things that I've already done. We're gonna do it together. So that being said, as you can see on the screen right now, the WAN IP is the 192.168.75.87. To be honest, that's my insecure devices LAN in my home network. So this device is in that area. So this device, even if it wants to, won't be able to talk to my NAS and other sensitive servers, proxmox, everything that I have. It doesn't matter for our video. And then there is a LAN range, which is 192.168.11, and that's the range we're going to deal with, and that's where I'm going to access it from. As you can see, this is 192.168.11, and this is literally fresh pfSense install. But generally, the concepts and things that I'm going to go through over in this video is going to help you in OpenSense as well. It's not really that different, okay? So some of the things that I mentioned in the previous video was one of the first things that you have to do is you have to make a decision, right? This is the WAN, this is SFP port, is actually the internet, and ETH0 is LAN. That's what we did. And then we created a VLAN, and with the ID of 50. And VLANs are, as I said, imagine how these two are separate interfaces. You see, that's ETH0, ETH1. They are physically separated. So you can basically have two separate switches and have two completely separate networks. So this one can be 192.168.1 up to 255, for instance, and this one could be 172.16.1.1 up to 255, and this one could be 10.1 up to 255, and so on, right? So you can physically separate them with the physical Ethernet devices, but also, let's say you want to use a single port, and that's the LAN port, but on the same LAN port, you want to connect it to a switch where all the devices in your home network are going to be connecting. What you can do is you can separate each one of them and put them in a separate virtual LANs, virtual networks, using the VLAN ID. In your switch, you can say, okay, this port can only be on the VLAN ID 50, and whatever device you plug in there is only going to be on the VLAN 50. So you can enforce that and have a virtual network, and then in your house, you can decide which device is going to be in which network, okay? You basically decide and make a decision, and based on that, you create the interfaces. It can be either physical or VLAN. And for VLAN, we went over it. Like, you create a VLAN, as you can see, you can just create a tag from 1 to 494. 1 is the default, so I shouldn't be using that. So you can do 2, but I don't recommend going very low, just close to 1. Just start somewhere higher so you can have better meaning and separate them better. So I start with 50. You can go with 500, right? So you just have to basically write what you want, and based on that, create the VLAN, and then go to interfaces and assign it. So you can do 50, and I already did 50. You can do 51 and give it a priority. So this is a priority if you're using it in a switch. Just ignore, leave it at default. And description, you can just go this one, secure devices, something like that. Doesn't matter. You create VLANs and descriptions so you keep in mind what is what. And then in the interface assignment, you assign them and add them. As you can see, it's here. You add them, and then you can go to interfaces. Now you will see those in here. And we went over that, and then we created IoT devices network, and I gave it a range 172.16.10.1. If you go to interfaces, you will see that is actually on this port, on the second port, and we can always test that, right? I put IoT devices on the second port, right? IGC1, and I said the second port will be on 172.16.10.1, right? If I go to my computer and if I go to my device, you will see that 192.168.1.100, right? right? But look what happens. If I take this out, I lost the connection. If I put it on the second port, now we wait. Okay, there you go. 172.16.10. 100. Now, if I want to access the firewall, I have to, you see, it doesn't work anymore. 192.168.1.1 is not accessible anymore. So what I have to do is use this IP range, which is 172.16.10.1, 172.16.10.1. And even that is not allowed because we didn't add a rule to allow this port to even access the admin panel, the pfSense. But let's say if we have access to internet, nope, that one is not there. Now let's go back to our original port and the original IP 192.168.1.1. Okay, so we are back. What happened that in the IoT devices it did not work, right? If we go to firewall rules, that's where the difference is. As you can see here, there's anti-lockout rule. Basically, no matter what in the rules, this one stays on top. That means that anyone in the LAN IP range, that any device connected to this port will be able to access the firewall on 44380 port. So they will be able to access the firewall admin panel, the interface, so they can fix things up. Sometimes you might add a rule that will block a lot of things and that will cause, you see, as you saw, I put this in here. It didn't work. And let's figure out why. If you go to IoT, there you go. There is absolutely no rule whatsoever for forwarding, for NATing, and for access to internet or anything like that. That's why when I connected my computer that I'm recording from to this port, I got the IP, but I couldn't access internet and I couldn't access the firewall. That's because there is nothing in here. But look at the LAN. As you can see, there is LAN subnets and it allows the access to the LAN and allows access basically to any, which is WAN is included. If we go to the WAN, there is no rule blocking it. So in terms of rules, what you can do is, here is basically what you're defining, and they always important in the order. So the top item in this page will be executed first. So if your rule matches, if your incoming packet matches the rule number 1, which is right here, this one will be executed first. So it means that if your computer in the LAN range is trying to access a destination in the LAN address, the whole range, on port 80 and 443, it is allowed. What you can do is you can basically create as many as rules as you want. Block, pass, and reject. So difference is in the reject, a packet TCP reset or ICMP port unreachable for UDP is returned to the sender. So sender will immediately know it was not allowed TCP reset or ICMP port unreachable in the UDP will be returned to the sender. That is on the reject. But on block, the requester will not know. What you will see that hanging page, you'll see that Chrome, let's say, is trying to load the page. So you define you want to pass, block, or reject. You can disable the rule or enable it, and you can say on which interface. So if you have a rule on a single interface, you can copy it easily to the other interface as well, but you just choose the interface, let's say LAN interface, and IP address family. I don't use IPv6 in my home network, so I usually just go with v4, but if you are using, you can enable both of them. And on the protocol, if you are trying to restrict a port access, you can go with a TCP or UDP or both, TCP UDP. If you're trying to just categorically block access, let's say, from devices in ETH1 to accessing any device on ETH0, you always go with any. You don't want ICMP, you don't want ping. As I said in the previous video, why would your light bulb would ever be even able to ping your NAS, right? I know it's not gonna ping, hopefully it won't ping, but let's say something happened for whatever reason, your light bulb starts pinging or accessing, trying to access your NAS for whatever reason, wherever you bought your light bulb, right? It should not be possible. How would you do that? You do that here. So what you can do is you can say the interface, let's do that. In the IoT devices interface, on this ETH0 interface, any device on that interface, source doesn't matter. Any device in that ETH1 interface. You can do it for a specific device or a specific client or whatever, doesn't matter, but here we go with any, and we say if the destination is a network, right? The whole network. You can say any device in the LAN address, okay? If anything in the IoT interface's address, try to access anything on the LAN address on any protocol on IPv4 or v6, just block it. That's what you can say here. And then you can save this and apply the changes, and it's gonna appear here. The rule doesn't matter. And you can move them around. As you can see, you can drag and drop. As I said, top rule, if it matches, if the request comes in to the IoT devices, it is IPv4 or IPv6. source port doesn't matter, destination port doesn't matter. But if the destination is an address in the LAN address range, it is going to be a match to this rule, and it will automatically immediately drop it. So if I have a second rule in here which says allow, right? If I say allow pass, right, it won't work because these two rules are identical. The top one is saying allow, the bottom one is saying reject. So let me save this. So whichever is on the top line and matches, that's going to be executed. So this is going to match and it's going to block it. So if you do it this way, so that's where the rules are. So you can create as many rules as you want in here. And what you can do is, let's say you want to create a rule for 6-7 IP addresses, not the whole range, but you see what I mean. Let's say you want to do IPv4 TCP and the source IP address is like 6 IP addresses, right? 192.168.1, 100 and 110 and 135, something like that, right? As you can see, there is no way to add 6-7 IP addresses right here. So what do you do in that case? You go with the alias, and aliases you can always create in here. So what that means is you can do aliases with IPs, with ports, URLs, and all, doesn't matter. We go with IP, self-explanatory. So here you say my development machines, right? You want your development machines to talk to each other on port 80 and 443, let's say. That's where you do. So you come here, you give it a name, and you give it a type is host or network ranges or ports or IPs. You go with hosts, and then you can say, okay, 192.168.1, 100, and add another one, 110, add another one, 135, and just save it. Now we added 3 hosts, and if I go to firewall and the rules, and I go to IoT or LAN devices, and I'm adding a device and adding a rule, I can say if the source is alias, and the alias, you just start typing my, you see, it shows up, my development machines. So now what it means is my development machines, if it is IPv4 and it's trying to access something, you can say custom from to, so you can say from port 80 up to port 444, doesn't matter, it will be able to access it. You can choose pass and allow it. Okay, so that's the alias, that's the rules, that's the interfaces. We covered 3 important topics. There are a lot of things in pfSense. It's going to be for very, very sophisticated advanced users and advanced situations. You're not gonna be needing a lot of them. Okay, so I'm gonna ignore those and focus on things that matters most to everyday users, like your home network and what you want to do. Another thing that it matters a lot is DHCP and DNS server. So there's 2 types. One is DNS forwarder. Basically, it doesn't do almost anything. It just forwards the DNS request to an upper level DNS server that you trust. You can say on which interfaces it should be listening and forwarding and all that stuff. I don't use this. I don't really recommend this. What I would say is use DNS resolver. So here you can have caching, you can have your own DNS entries in the firewall level, and you can also do pfBlocker, which is you can use to block ads or block certain type of categories of site. Let's say adult sites. You want to block it throughout your house, you can do that in the pfBlocker. Let me show you. So in here, first of all, you can have host overrides, right? What that means is it's going to error out, but let's try with some site. Okay, so first of all, as you can see in my network, if we go to my network devices, this host computer that I'm recording from, as you can see now in the details, the DNS resolver and DHCP server is my pfSense box. So the computer that I'm recording from is resolving all the DNS requests through the pfSense. That's in this device. Okay, keep that in mind. Now look what happens. I can't do it with like the top level big domains, let's say Reddit or Yahoo or Google or stuff like that, because there is a security feature in Google that have certificate pinning for big sites. So here, let's test the internet first. Let's say google.com. Okay, that is resolved. Okay, so let's say if we do ns lookup google.com, you will see that our pfSense test machine is the one resolving and returning the results. So now let's say if I do ns lookup for some other domain, let's say Netgate. Okay, if I Google Netgate, it's netgate.com. You will see that I'm getting this IP address, right? 199.60.103.104. Okay, and if I try to do Netgate, you see it loads the Netgate website. But what you can do in the DNS resolver, you can come here in the host overrides for certain interfaces if you want to, and we'll go through options. But look what happens. So you can say for the host, which is, let's say, www, right? Or nothing. And in here, you can say netgate, so www.netgate.com. And you can say the IP address is 192.168.1.1. Yeah, the firewall IP address, okay? And for the host name and alias, you can also add www and save this. So here you can add www. Without it, we can say netgate.com. Description, we can say block netgate. Okay, we save that, see what happens. So here what we are going to say, www.netgate.com is going to be resolving to 192.168.1.1. And the description, I'm saying I'm just trying to block netgate. So anyone tries to access netgate.com, the IP address that should come back should be the 192.168. So if we look it up again, still there because of the cache. So what I can do is I can say ipconfig//dns. Okay, let's retry www. There we go. So now we are getting the netgate as 192.168.1.1. So if we go back again to netgate and try to load the netgate website, you're going to see that it gets stuck. And there you go. Now it is trying to access the firewall, but because Chrome cached the previous CA, all that blah, 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 ignore this. This is all about the SSL security. What I wanted to show you is that you can override hosts with this, which is kind of logic behind pfBlocker as well. So instead of using this for blocking, what I personally use this for is actually something else. So what I do is I give names to certain devices in my network. So let's say I have nginx proxy, right? So I say nginx proxy.homenet. That's my home network and just made up domain. So I say nginx proxy.homenet, and you can say www over here as well, www.nginxproxy.homenet, and you can say resolve that to 192.168.1.100, and that 100 is actually the device that's running my nginx proxy in my home network. And I can do that and save this, and if I ping throughout my home network, if I just type in nginxproxy.homenet, you will see that it will resolve to the IP address that I just defined. There you go, 192.168.100. Okay, so this is what I'm using it for, mainly to override and have my own DNS server in my home network, and all my devices have a name. Now you might say, okay, you're resolving it to an IP address, but these devices are all on the DHCP and it's going to change the IP address. What would you do for those cases? Very good point. What I do for those cases is the second thing that I want to show you, which is the DHCP server. In the DHCP server, what you can do is you can add static mapping. So in order to do that, you just have to find the MAC address of the device. So in this case, let's say it's the MAC address of my computer, that 1100, right? So what I can do is, first of all, I can go to ARP table, and here you will see a list of almost all devices in your network. You will see them in here. So as you can see, this is my home computer. That's the computer that I'm recording from. As you can see, if we go to the network settings in here, and if we go to details, you will see that I am 192.168.1.100. That's the name. And because I added a host name, the DNS entry to it, as you can see, the pfSense is resolving that as well. So it will show up in all the logs with the name as well. Okay. So what I can do is here, I already figured out the MAC address of my computer. I didn't even know, but now I know that's my MAC address. So what I can do is I can go to the DHCP server and add a static mapping. On the MAC address, I paste it, and client identifier doesn't matter. So IP address, what I can say is bind this device to 192.168.1.100, and also create a static entry in the for MAC and IP pair in the ARP table, ARP cache table. And the host name, you don't need to. Description, you can say my nginx proxy machine. By the way, the IP address should be out of the range of the devices that you created for the DHCP. That's why in the DHCP server range, as you can see, it starts from 10, goes up to 245. So you have to change your range, start from 10. So in the DHCP mapping, you have to say 9, okay? So you paste the MAC address, you can say 192.168.1.9. This will work, okay? And if I save this, I can save and enable this, so it will always, my computer that I'm recording from will always have the IP address of 192.168.1.9. And now that you made the IP address almost static, although it's getting it from the DHCP server, now you can go to DNS settings and add a static entry for this IP address for any host name that you want. You got the relation? Good. Another thing I wanted to show you, I just kind of skipped over it. There is not much going on in here. You just have to add the DNS server settings. If you don't want to, you can skip it. Gateway is always default, and this is the range. So always start from 100, go up to 245. for all the DHCP ranges, that's what I do, unless you are in a network that you know you are going to have more than 155 devices, right? So this here, you can go to 54 and here 100. So it'll leave the first 100 to devices that you want to go static, and the devices matters a little bit more, I would say. But you do whatever you want. They are totally free. You can go from, let's say, 2, start from 2. The 1 is always the gateway. Start from 2, you can go all the way up to 200 and use the remaining 50 for static IPs and devices like that. Okay, that's another thing. One more thing, in the DNS resolver, I just want to show you these options. So you have it always listening on port 53, both on TCP and UDP. Okay, you can also enable the 853, which is the secure DNS over the SSL TLS. And not many client devices I know will use it, but if you have a device that use it and can use 853 port, you can do that. But you are already in your home network and you are just from your device, you're talking to your firewall to resolve a DNS entry. I don't think you really needed the SSL right there, but from your firewall up to your DNS provider, if you can enable 853 SSL based SSL TLS queries, DNS over SSL, that's good. I would highly recommend doing that. And there are certain providers like the Cloudflare, they allow that. So I would go with that and use that. So in here, in the network interfaces, you can define which interfaces you want your DNS resolver to listen on. I wouldn't recommend using it on WAN, obviously. So you will be resolving for everyone. If you open up the port 53 to the internet, you don't need that. And outgoing interface, you can say, okay, that's WAN. So it will send the traffic packets through WAN to resolve it. And the other thing is DNSSEC. You can enable it if you want to. It's a long story. We're not going to go there. Python module, if you enable it, it's going to help with the pfBlocker and do the things faster, which we are going to do next. Pre-validator, these are stuff for pfBlocker and other stuff like that. And DNS query forwarding. So what it does is I already defined the DNS server in general setup page. So it will first look on its own which IP addresses in here and pfBlocker and the cache and all that stuff. And if the answer is not here, it will use the forwarding mode. It will send it to upstream DNS server, resolve it there, and send a response back to the client in your network. So you can say, yeah, use SSL TLS for outgoing requests. But if you do that, you have to make sure that whatever DNS server you are using in your general setup is supporting that. So you can Google it, Cloudflare DNS over TLS IP. Yeah, 11111. So if you go to the general setup in the DNS server settings, if you do 11111 here, you can go back to the services in the DNS resolver and enable this option. Now all the requests that is going out of your home network to the internet to Cloudflare, and it's going to be SSL encrypted. So your ISP cannot see the domains that you're trying to resolve and access. Okay, so that's a good practice if you don't want your ISP to know what you're doing, right? But as you know, Cloudflare will know. So you can choose whatever DNS you want. So you can host your own DNS server on Amazon Cloud and use that if you want to. So we went through important things. The DNS resolver, the DHCP resolver, NTP doesn't really matter, PPOE, the VPN stuff, SNMP and other stuff, these are not that important. Not for like a regular home user setup. Okay, so things that you can use for troubleshooting. Okay, pfBlocker, we're going to cover it, but sometimes some things does not work. Like you're trying to access a certain port, doesn't work. You can always go to system logs. So there are different types of logs. If you have a hardware issues, a boot issues, you will see that in here. But firewall is where the blocking things are happening. So when you try to access a certain port and it's not working, you can very quickly come over here and search that IP address, source or destination, whatever you're trying to access it, you will see it in here. And then if you don't like the reason it's getting blocked, you can always block it if it is not blocked, or you can whitelist it and unblock it and pass traffic, easy pass create rule out of it, or you will know what is blocking it. So just the log of all the stats of all the devices in your network. DHCP logs, this is very helpful. I actually do it for all my videos. You guys don't see it, but let's say I'm reviewing this box, right? There's a Raspberry Pi 5 on it. I plug an Ethernet cable to it, right? I haven't connected the HDMI port. Okay, better example would be the module that I had, Desk Pi 6. I had 6 CM4 modules connected to it. I didn't know what IP addresses they have. Their HDMI is on the first one. So what I do is I always go to my firewall and I watch it here, and I will see the devices that they are coming. And usually the MAC addresses of them are like one up on each one. Like this first one is 0000 001, 02, 03, or just watch the DHCP server and you will see the IP addresses that are getting resolved. And from here, I see those new devices getting connected to my network and I catch the IP address from the DHCP logs. Okay. If you're using OpenVPN, which you can do, absolutely, which I do, can be used to dial into your home network when you're outside of your home network. So let's say you have a NAS in your home and you are out and you want to be able to dial into your home network and then access your NAS and retrieve a file. So for that, you can come to the OpenVPN in here and just create a server. But just remember, whatever port you're listening on, you have to open it up on the WAN, and it means you're opening up a port to the world. I'm not saying it is a big issue because so far publicly there are no 0 days that I'm aware of. There's no vulnerabilities known to anyone. Never heard of a recent, at least in a couple, maybe 6, 7, 8, 10 years, I haven't heard someone remotely exploiting OpenVPN server and dropping a shell or getting access to your pfSense box. If you know some, please let me know down below. I never heard of it personally. So you can create an OpenVPN server. There are a lot of settings in here, tunnel or tap device. I always go with 2, and then you can say you want it on the UDP, TCP, or both, and then you want it obviously to listen on WAN. I don't think you will need it on your LAN, so you define it on the WAN. Default port is 1194, but I would highly recommend not using the default port. As I just told you, there are no vulnerabilities in pfSense, but when you can, why not? Just hide it. So go for like 5-digit numbers. So I would recommend going, I don't know, 45,887. Very high above, out of scanning ranges of those bots that scan the whole network and whole IP address, and go with the UDP. So TCP, the scanners that are scanning the internet will know that port is open, but UDP they might, but it's not that easy. So there's also, I don't know that much of a scanning that happening on UDP. Yeah, just go with UDP and a high port, less likely of anyone detecting that you're running an OpenVPN server in your home network. It is still not too secret, but harder to find. Okay, and then there are settings. You can change the encryption settings in here. Default values are good, to be honest. These AES based and Cha-Cha ones are always good. I wouldn't change any. And in here, always use the hardware crypto. Will be much faster, trust me. So enable the hardware crypto if your device supports. In this case, this device does, and certificate and all that stuff. So these are for tunneling and OpenVPN. That's its own thing, so we're not gonna go that deep into it. Another thing is always look in the ARP table. You will always see almost all devices in your network in here, their MAC addresses and IP addresses and the host name. So if you are lost, you're looking for a device in your network, you don't know where it is, come to the ARP table. You're most likely gonna find it, but it's not always bulletproof. It's not 100%, but you most likely will find it. There is packet capture. So let's say you are investigating a device. The device only accepts Ethernet port and you just want to connect it to your firewall, let it connect to the internet, but also want to capture the packets. You can do it right here with the rules and everything. You can capture the packets and inspect, and it will give you a PCAP file which you can load it in Wireshark and investigate. pfTop will show you the current situation in your firewall, which host is talking to which IP, so you will have a stat on your network and the bytes it's sending and receiving, and as you can see, it's getting updated. So you will be able to see right now what's happening in your network. In the other stuff, you can shut down the system DNS lookup. So you want to know if your DNS resolver is failing in your client device or your pfSense is failing, you can come here and try to resolve a host and see if it can resolve it. The other stuff that matters in here, states the same as like the other firewall states, system activity, trace route, all that stuff. You will have a lot of things in here, but like edit file if you want to edit something. And by the way, always come to this backup and restore and back up your whole firewall settings once you set things up. Like you change things in the DNS and the DHCP and IP addresses and interfaces and VLANs, always take a backup. This device, right? I had the case, I had personal experience. My device failed and I was back and working in matter of hours, like 1 hour maybe. I just found a new device, turned it into pfSense, I restored my old firewall log, even if it is a new device. Minor changes to interfaces and MAC address because it is binded to the old MAC address and IP addresses. Little change and I was up and running very quickly. If you don't do it, whatever you're doing in the firewall, it's all gonna be lost if this device fails for whatever reason, okay? So come here and you can select the settings. I don't skip packages. I wanted to know which packages I was using. So for instance, the pfBlockerNG. You can keep it, so don't select this. And this is the data stuff. I don't care, I take that as well, and also extra data. So I want to back up everything, and what you can do is you can encrypt the backup file and enter a password, but just remember, keep that in a secure place, because if you lose that password, also you won't be able to restore it. So if your firewall crashes and you don't remember the password, your data is gone. Okay, one other thing that I kept saying about it in the beginning of the video is the important packages to remember. So one of them is pfBlockerNG, and developer or like testing version, and this is stable. Honestly, I don't want to recommend, but I am going to. The development is more up to date and gets the features and bug fixes faster, and I really never had issues with it for past years. So I am going to install the developer version. Okay, so that's the pfBlocker, but if you don't want to take any chances, go with the stable version. Okay, so if we go to available packages, the other things that matter, so let me show you a couple more things. So remember I was talking about Nginx proxy. If you want, you can use HA proxy. HA proxy, you can use this to basically do load balancing and port forwarding. So you can say anyone accessing www.test.homenet, load it through the proxy, and you can use DNS and SSL and all that stuff. So that's HA proxy. Maybe not very much for the home user. I would still go with Nginx proxy in the home network. That's what I'm doing. The other packages, Nmap is used for scanning. You can install it on the firewall and scan network in the firewall if you want to. And if you're using OpenVPN, I would definitely use OpenVPN client export. It makes it easy to create a client profile which you can load up in your phone and then connect to your home network using the OpenVPN client export. pfBlockerNG, we installed the developer version. Snort, as I was talking about it in the previous video, is an IDS, right? It detects exploits, attempts, and scanners that are scanning for open ports and all that stuff. Other alternative is Suricata. So if you don't like Snort, you can go with Suricata. But I personally, I have more experience with Snort. I've been using Snort. Yeah, I'm happy with it. WireGuard is there also, by the way, if you want a more modern, faster VPN. OpenVPN been around for a long time. It is good, it's stable, it's fast, but not as fast as WireGuard. WireGuard is blazing fast, and it's more recent, new, and I'm gonna say state of cryptography. It is using a lot of fancy stream ciphers and all that stuff. I would go with WireGuard if you don't really need OpenVPN and you need a fast connection to your home network, but you do you. Once you install the pfBlocker, so you can go through the settings and wizard in here. You can say inbound interface is actually your LAN, and you hold the control, you select multi-select. So these are your LAN. Outgoing is WAN. Okay, you select that. And this is the virtual IP address of the DNS blocker, DNSBL. I don't touch this, leave it, unless you need that IP address range and you're using it in your real LAN or WAN, then change it. But if you're not, leave it as is. Also the port and SSL port, I wouldn't touch it, leave it. What it means is basically when pfBlocker blocks a domain, blocks an ad website or whatever site you're trying to block, it will return this IP address, which is 10.10.10.1. Okay, so and then it will load up a pfBlocker error page, and it's going to say your firewall is blocking access to this page, whatever, right? So you finish that wizard and setup, and then the important thing is you have to feed it with DNS blocker feed. So as you can see, it's downloading and resolving some IP blocker and whatnot. So what you can do is go to general settings. First of all, these are the log settings and all that stuff, does not really matter. IP address here, if you want, you can get a maximize account ID and license key. There are links in here, explains how to do it. So if you do that, you can do a blocking using a geo IP. So you can say, okay, if any device in my home network tried to access, I don't know, African IP or Asian IP, or let's say you don't have any business accessing sites in certain country, I don't know, let's say Cambodia or just some country, you can block it in here with geo IP. You can say block geo IP top spammers, that's there, but also you can say block the whole Africa or Asia or Europe or North America, Oceania, whatever you're not supposed to be accessing it, you can block it with geo IP. And you can do it with IP range and the IP lists, right? So you can get a lot of IP lists of ad serving IP ranges or IP addresses of the sites that you want to block. There is also DNSBL, which is with the DNS with domain name, and you can create a DNS group, add basic. As you can see, it does have some ad blocking, which is reading this host. And if you open it up, you will see it's a log long list of domains that are, serving ads apparently, okay? So if we copy one example, care.help.com, and if we make sure that the pfBlocker is actually up and running, which it is, okay? And if I go here and try to resolve one of those ad serving sites, there you go. That's exactly what I told you, 10, 10, 10, 1. And if you try to load that page up in your browser, you will see this error page. It will tell you that DNSBL ads basic group in DNSBL is blocking this ad website. Okay, so sometimes my home network, I actually have a gigantic list of feeds that I found over time on the internet, and my DNSBL group is multiple items. Okay, so sometimes these feeds block a website that somehow you need it. Maybe it's false positive on their end. Maybe it is actually serving ads, but also you need to access it. Or in my case, sometimes, let's say Netflix doesn't load because it can't load the ad website. It's not Netflix, I'm just giving you an example. Let's say your Amazon mobile app is not actually working or functioning properly because it's trying to resolve a domain which is serving ads, and it starts crashing, it doesn't work. This is a real case. So what happens in that case is you have to come here, you can go to reports, and as you can see, it detected that my computer tried to resolve this IP address. And now let's say you want to say, okay, this is false positive. I actually want people ads in my network, but just this single host is actually false positive. I want people to access it. I want them to open actual real care.help.360.cn, whatever that is, I don't even know. So you can click on the plus icon in here and then say yes, and you can say you're trying to whitelist the wildcard, the whole, you see it explains here, star.care.help, or just the literal care.help.com. That's what we are trying to do. We're trying to do one domain. You select on whitelist. It says, do you want to add a description? This is helpful if sometimes you want to block something for now, get things done, but then you want to block it back again. It's good to add a description so later you remember, and I will show you where this will show up and you will see that. So let me actually do that. So we can click on OK, whitelist, then yes, and I can say testing, right? Just something. There you go. Now, if I come to DNS blocker and if I come here to the DNS block whitelist, you will see these are the sites that are whitelisted, and on the very, very bottom, you will see the care.help.360.cn and www.care.help.cn. Testing with that tag name, with that comment, is in the bottom. So later you regret what you did, you can just delete this and save it, and it will go back to blocking it. So before I do that, let's see. There you go. Now it's resolving it, okay, because I whitelisted it. But if I save it now to clear the DNS cache and all that stuff and look it up again, you will see that it is getting blocked again. Let's try. Okay, DNS cache is there. You get the point. So another thing is DNS blocking in safe search. So you know how in Google you can search certain keyword and it might have a NSFW, right? So you can say, okay, if somebody tried to do safe search, redirect it, okay? Basically, if somebody tried to disable that safe search, it will prevent it. Same thing with YouTube. You can say, be strict. Let's say you want to create a VLAN called kids for your kids, and all your kids' devices will connect to that Ethernet port or router or switch or Wi-Fi router. You can say on that network, be strict on YouTube and even safe search. So if they go to images.google.com, right? Let's say you search something explicit. So I just searched NSFW. So you see the safe search, right? It is saying blur it or off. You can just turn off the NSFW completely or filter it, right? So if you come to the pfSense, you can say enable it. So even if your kids try to block on disable that, it will force the NSFW blocking. It won't let them to bypass that. Another thing that you can do, you have to also prevent any devices in your network to use external DNS resolvers, because if your kid's device somehow someone figured out or something happened, your Apple device or whatever, tried to use 1111 or 8888, 8844, Google DNS resolver or whatever, bypassing your DNS resolver, they will basically bypass all the blocking that you're doing over here, okay? So in order to prevent that, also here, there is DNS blocking with the category. There is shallow list and UT1 list. So if you come here and just search adult, let's see, here in UT1, there we go. If you want to block all all the adult websites, you just have to select the category. It will categorically block adult websites in your whole network, okay? So when you do this, as I said, if somehow devices in your network, instead of using your firewall pfSense as a DNS resolver, use some other public DNS resolvers, whatever you're doing is just useless. So what you have to do is you have to come to the rules and say, if any device in the LAN, or let's say this is kids LAN, kids network, kids VLAN, doesn't matter, whatever you want to do, you go here, add a rule, you say reject or block, doesn't matter. You say the source is IPv4, let's keep it TCP or UDP, okay? And source device does not matter. Destination device does not matter. But if the destination port is 53, you have to say block it, okay? You can or just say select DNS over here. So you say if, and you have to put this rule after whitelisting access and request to the firewall itself, which is here, right? So what you can do is you can add another one and say IPv4 TCP or UDP, okay? And you can say source doesn't matter, destination, this firewall, the device itself, on the port DNS, this one, pass it, allow it, okay? So you save this, okay? So here's the rules. If the request is coming and the destination port is 53, allow it. But if it is anything else, block it. So if they try to access anything out of your firewall, that's not your firewall, but they're trying to access it on port 53, and you have to copy this rule and make another one for port 853. If they try to do that, block it, drop it, don't allow it. So you have to do this and block access to public DNS providers. You can even go crazier and do it with the IP addresses. So you can say, okay, if the destination is address or alias, and in the address you can say, you know, 1111, and create an alias for all the public DNS providers, 8888, 8844, and so on, okay? You can create a DNS list of public DNS providers, add it, and block it. So don't allow any device in your kids' LAN to access those public DNS providers, so you can do that as well in here. So that's really it. It's the most basic things. I had to cover the important things, and that's really it. The other stuff are really advanced things like on the firewall and NAT, things that you can do in the optimization section. There are a lot of blog posts about it on how to do certain things. There are some even system tunables. You can change these. If you have 10 gigabit Ethernet or even higher, you want to do faster things, there are guides on how to do that. I'm not going to cover it. I wanted to make this video simple and for everyone. Okay, so you learned about interfaces and their assignments. You learn about the VLANs. You learn about the pfBlocker, DNS server resolver, DHCP resolver, OpenVPN a little bit, and using how to use the system and the status and diagnostics and how to troubleshoot issues, and some tricks like using the DHCP static resolver for the last 50 IP range, and then using those static IP mappings to MAC address in the DNS resolver to create your own home network DNS and DNS resolving. So all your devices in your network can have a host name, which you can use it in your browser and your apps and all that stuff. Widgets, basically, you can move this around, add more widgets with clicking on here. The status of IPsec and gateways and interfaces, all that stuff. It's just the fancy things. You can modify your dashboard to look different. So just so you know, you can remove this Netgate stuff as well. It's all up to you what you want. You set your own things. If you don't want to deal with Netgate, you can use OpenSense instead of pfSense. So the concept of most things that I covered in this video will apply there as well. It just have a little bit more modern, honestly, better UI to be fair, but it's just something I haven't used much. I have deployed a lot of pfSense and I have Netgate licenses and all that stuff. So it's up to you. You decided, but I just wanted to cover the concept, okay? Let me know if you have any specific questions, and hope this video was helpful. Thanks for watching, and I will see you in the next video. Bye for now.